My name is Zach J, and I'm a tutor here at Chegg.com/tutors. And today I'm going to be talking to you about a rather massive topic of the different methods of solving quadratics. Total in this video, I'm going to show you 5 different ways to solve these types of problems. And so let's get started. So the first thing I want to mention about quadratics is when we do these solvings, we're always going to we're always going to be looking for when the equation crosses the x-axis. So like here and here. And we're going to do that by setting y equal to 0, because on the y-axis, if it is equal to 0, our equation is then crossing the x-axis. And then we'll subsequently solve for the x values that are at those 0 y values, okay? Also, quadratics take the form of ax squared plus bx plus c. And so we will be using and referring to the different terms in the equations by a, b, and c, okay? Okay, so let's get started with the first method. So the first method is solution by square root when the b term is 0. So if we look here, this b term is 0, 0 times x, this term cancels out. We're just left with ax squared plus c. Okay, so here we have the ax squared plus c. And so, like I said in the first, in all these problems, we're going to be setting them equal to 0 to find out where they cross the x-axis. In this case, this problem is pretty easy. So I just need to move this 16 to this side, so I add 16 to both sides. 16 plus negative 16 is 0, and so x squared is equal to 16. And now I take the square root to undo this square root of here, and so x is equal to, and the square root of 16 is 4. And because I took the square root, very important not to forget plus or minus 4. Okay, so that's my answers to this. So in this case, this looks very similar to this here. With the x-axis, it will cross here. This will be negative 4. This will be positive 4. Okay, so that's what's happening with this equation here. So the next method we get to is factoring. So factoring is a little more complicated because we do have this b term in here. And so what we're going to do in factoring is move all the terms to the left side and set them equal to 0. So in this case, we have a negative 2x here, so we need to move that to the right side. So I'm going to add 2x to this side. Okay, so when I add 2x to this side, that becomes minus 5x. I need to bring down this x squared term. And then here on the left, we have negative 9 right here. And so I'm going to add plus 9 to get this to this side. And so plus 9 minus 3 is positive 6. Alright, and that is equal to 0. Okay, so now that I have this in the ax squared plus bx plus c form, I now will do factoring. So when I factor, I think of this c term here. And so this c term is 6. So now I need to find the multiples of 6. And the multiples of 6 are 1 times 6 and 2 times 3. If I kept going, I would get 3 times 2 and 6 times 1, but those are really the same thing as here. Now to determine which set of numbers I'll use, I have to figure out which ones will add to be negative 5. In this case, 2 plus 3 is 5, and so that will be the numbers that I will use. Okay. So when I factor, I have 2 parentheses multiplied together. Those are going to equal 0. And so the first thing I'm going to add here is this x, right? So x, and then multiplied by x, is x squared. Now from here, I decided what my other terms in here will be. So that'll be a 2 and a 3. Now I have to decide if this is going to be plus minus or plus minus in here and here. Are we going to basically, are we going to subtract 2 from the x, or add 2 to the x and add 3 to the x, or subtract 3 to the x here? So the way I determine what my signs are is from here. So I have to have these two add to negative 5. and multiply to be positive 6, because when I FOIL, I'll end up adding and multiplying. Okay, so to make it negative, both of them have to be negative. So negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is positive 6. So that works. So this right here is my factored equation. Now, since these are both set equal to 0, I can then rewrite this as x minus 2 is equal to 0, and x minus 3 is equal to 0. And I can do this because whatever my x term is here, if this is equal to, in this case it's 3, x will equal to 3. When x is equal to 3, this term becomes 0. And although this term is equal to 1 when x is 3, 3 times 0 is 0, and that satisfies the equality. Okay? And the same thing happens when x is equal to 2 here, when I solve for x, in this case, adding 2 to both sides. Okay? So then my two answers for this equation, and there will always be two answers when we're talking about these quadratics because we have a squared term, will be 2 and 3. Okay? The next method is completing the squares. And this method is a little difficult, but we'll be able to get through it. Okay? So with completing the squares, what I'm going to do is look at this b term. And the first thing I do in this method is that I take the b and I take 1/2 of it, and then I square it. Okay? And so when I do this to this b, 1/2 of 10 is 5, and then I square that, and that gives me 25. Okay? So 25. So that's what I'm going to add to each side of this equation. This is equal to 0. So the first thing I'm going to do is move this 11 to the other side. So it's going to give me x squared plus 10x is equal to 11. And now I'm going to add 25 to both sides. And I can do this because if I subtract 25 from both sides, it's like adding 0. Okay? So I can actually do this mathematically. So plus 25 plus 25. Right? So if I subtract 25 here, I have to do it from this side too, and that gives me 0 and 0. Okay. So now I have on this side something that I can factor, and I do the same thing I did in the last example by taking the factors of 25, or the multiples of 25. So that's 25 times 1 is equal to 25, and 5 times 5 is equal to 25. Okay? And to determine which ones I use, I see which ones add to 10, and that will be 5 times 5. Okay? So then I do the same thing. I take x plus minus the term times x plus minus the term, and then I have to decide if it's plus or minus. In this case, it will be positive because I need to add the 5's together to get the 10 and multiply them together to get the 25. Okay, so this is my factored out form. On this side, I can go ahead and add these and get 36. Okay, so now because I have x plus 5 times x plus 5, that's the same as saying x plus 5 squared. So I can rewrite that like that and get x plus 5 squared is equal to 36. And then I can solve for x. So I take the square root of each side. Square root of something squared is just itself, so x plus 5. And that is equal to the square root of 36, which is 6. And also remembering it's plus minus 6 because it's a square root. Okay, so now we have two different cases to solve for x in, the plus and the minus. In the plus case, x is going to equal, so this will be, if I move this 5 to the other side, I get minus 5. Okay, so plus, so 6 minus 5 is 1. And in the other case, I have x equal to negative 6 minus 5, or negative 11. So that's my two different answers for this equation, 1 and negative 11. Okay? So I'm going to use the same exact equation and solve it with this other method called the quadratic equation. And the quadratic equation is this big long thing here. Negative b plus minus b squared minus 4ac all over 2a. If I were you, I would remember this. It's useful for the rest of your life, as long as you're in any type of math class, including physics, Very, very useful, and I use it all the time. Okay, a little bit of terminology here. This term inside this radical is called the discriminant. Just a little bit of terminology for you. Okay, so let's go ahead and solve this problem. Remembering that the coefficient in front of this x is the a, this 10 is the b, and this 11 is the c, and that comes from this equation here on page 1. Okay, so plugging in, negative b will be negative 10, smaller, plus minus b squared, so that's 10 squared, minus 4 times a is 1, times c is negative 11, all divided by 2 times a is 1, so 2. Okay, and that's what x is equal to. So we go ahead and solve what this discriminant is. 10 squared is 100, minus 4 times 11 is 44, negative 44, minus a negative is addition, and so it'll be square root 144. So x is equal to negative 10 plus minus square root 144, all divided by 2. Square root 144 is 12, so x is equal to negative 10 plus minus 12 by 2. Okay, and then we solve x for each form, the plus and the minus. So when x is, when we do the plus form, it'll be negative 10 plus 12, which is 2, divided by 2, which is 1. And in the negative form, negative 10 minus 12 is negative 22, divided by 2 is negative 11. And you'll see that this is 1 and negative 11 are the same answers that we got by the completing the squares method. Okay. And finally, the last method you can use to solve this is graphically. So if you have, a handy dandy calculator that graphs, you can go ahead and plug this formula in and see where it crosses the x-axis. And if we do that, we will see that it'll come down here through x negative 11, come all the way around, and then come up through x is 1. And I know this because I've already solved for x on each of these equations, and I know the points where these go through when x is 0. Okay? And a little note, if the graph does not intersect this axis here, all the roots are imaginary, and so that's like when we have a root of a negative number. Okay? So those are imaginary roots. Okay? And those are a little more difficult to solve for, and in those cases we would have to do a separate video for that, which I'm sure will be coming out soon on the Chegg website here on YouTube. Okay, so if you have any questions about how to solve any of these problems, I know there are more difficult examples of all these different types of methods to solve. So if you have any questions with those, please reach out to either myself or any of the other Chegg.com tutors, and we will be happy to help you with those. Until next time, have a great rest of your day. Goodbye.